Hey guys, Dr. Brown here, and tonight we're working an integration problem for you Calculus 2 folks. And it's the integral of x squared tangent inverse tangent, so the integral of x squared tangent inverse x dx. So hopefully you know your inverse tangents here. All right, let's get after it. If we have, what are our tools? We have U sub, trig sub, integration by parts, partial fractions, power reduction, long division, completing the square, and we added one, the method of quadratics. Okay, so those are our tools in our toolbox. And with this one, I probably would like to take integration by parts, I think's what I'll do. But there's a few rules that we need to understand when you're working with integration by parts. Okay, well, working with tangent inverse, I should say. If you have tangent, and this could be tangent inverse x, sine inverse x, cosine inverse x, that's theta. You know, when you have the angle, let's say I have 1 square root 3, 2. Okay, that is 30-degree angle here. If I said sine of theta equals 1/2, if I want to understand theta, then I would say sine inverse of 1/2, and that equals my angle. So if you were to put sine inverse 1/2 in your calculator, you'll get 30 degrees. Tangent would be the same. If I had tangent of theta, it equals 1 over square root 3, so tangent inverse 1 over square root of 3 equals 30 degrees. We have that situation right here. Tangent inverse x, that is theta. So all of this right here is theta. That's my angle. So hold that thought. Now let's look at integration by parts, and we're going to use the DI method. It's just same as the old school integration. Remember, you had the U and the DV, and you work from that. Same concept, except this helps you keep up with the signs. This is a super great method. Okay. So when you look at this, you say, which piece of this can I integrate easily? Oh, tangent inverse x. How do I integrate that? Remember I said easily. Okay, let's skip that one. I can integrate x squared, so I'm going to write that here. Tangent inverse x. Okay. I need to take the derivative of tangent inverse x. Remember, I said tangent inverse, or the inverse could be sine inverse, cosine inverse. The inverse of any of those is the theta. So if I can write an equation for d theta, that in effect would be the derivative. So if theta equals tangent inverse x, it implies that tangent theta equals x over 1, because that's x over 1. So I have this triangle here that looks like this. Tangent of theta, can you see that? Yeah, is x over 1. So that tells me that this is x squared plus 1 squared, which is just 1, square root of that, okay? All right, so back to this. Now then, let me take the derivative of tangent theta. So if I were to take the derivative of that, actually of all of this, derivative of tangent would be secant squared theta d theta, and that equals dx. So d theta, if I divide both sides by secant squared, then I get 1 over secant squared theta which is what? Cosine theta, cosine squared theta. So that equals d theta. So d theta equals cosine squared theta. All right, so what is cosine squared? Cosine would be, of theta would be the adjacent over the hypotenuse. So that would equal 1 over the square root of x squared plus 1. But it's not cosine theta, it's cosine squared. So I need to square all of that. All right, let's go right here. So that d theta then would equal 1 squared is 1. If I take this square root and square that, the radical sign drops away. So I end up with x squared plus 1. Okay, d theta is 1 over x squared plus 1. So d theta, excuse me just a minute, I had something pop up on my screen here. Okay, so d theta then is the derivative. If theta is tangent inverse x, d theta then is the inverse or the derivative of that. Okay, so I have 1 over x squared plus 1. That's the derivative. Now the integral of x squared would be increase that by 1, which would be x cubed, divided by 3, which would be 1/3 times x cubed. All right. Let me erase all of this here, get it out of the way. Now then, within the DI method, you're looking at the diagonals, multiplying those, but you're also integrating a row. And that's the stop. When I can integrate a row, that's when I stop, or I end up with the derivative down to 0, or it repeats itself. Those are the 3 stops. Okay, so what do we have here? We have 1/3 x cubed. And by the way, that's positive, positive, positive. So all of these are positives. 1/3 x cubed tangent inverse x minus integral, excuse me just a minute. Sorry, I had to confirm my Wi-Fi was still running. Okay, so we had 1/3 x cubed tangent inverse x minus that integral. So we have 1/3, we'll bring it to the outside, x cubed over x squared plus 1 dx. What to do with that guy? Okay, u sub, remember our tools. U sub's number 1. All right, so let's let u equal x squared plus, well, let's do this over here. U equals x squared plus 1. Okay, du, if I take the derivative of that, 2x plus 1, the derivative of a constant 0, so 2x dx. So du divided by 2x equals dx. All right. So now we'll work with this one. 1/3 the integral of x cubed over u, and then dx is du over 2x. So that cancels one of those. So I have minus 1/3 the integral of x squared du. Actually, that 1/2 times 1/3 gives me 1/6 over u. Du over u times x squared. Because one of those canceled with that. X squared, what do we do with that one? Well, if I subtract 1 from both sides, u minus 1 equals x squared. So I can replace this x squared with u minus 1 du. So I now have 1/6 u over the integral of u over u du. Negative, negative gives me a positive 1/6 the integral of du over u. Okay, let's bring this guy down here. We had 1/3 x cubed tangent inverse x minus all these other things. Okay, so 1/3 x cubed tangent inverse x minus 1/6 u over u is 1, the integral of du is u, plus 1/6 natural log of du of natural log of u. Okay. Well, what was u? U was x squared plus 1. So we have 1/3 x cubed tangent inverse x minus 1/6 x squared plus 1 plus 1/6 natural log of x squared plus 1 plus c. And that, my friend, would be the integral of x squared tangent inverse x. Now a person might say, hey, how do we know that's correct? Well, you'd take the derivative of that. Keep watching in another video and we'll do that. All right, why are we doing these things? Okay, together we're trying to build a better tomorrow, and do that how? Do that through math. Keep studying, 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 okay? I can't overemphasize that. Practice makes perfect. At least it improves you, okay? All right, that's all for now. Talk to you next time. Thanks.